Singapore is a leading global maritime hub as the world's busiest container transshipment port and the biggest bunkering hub. Maintaining safe and effective navigation for a large number and variety of vessels is a prime concern. The COREX rules provide protocols for one-on-one close encounters. However, the rules are limited in addressing situations involving multiple vessels converging and vessels with varying maneuverability. This becomes an area of concern for ships navigating the busy traffic in Singapore waters. Through collaborative approach and with funding support from the Maritime Port Authority of Singapore and the Singapore Maritime Institute, the Centre of Excellence in Modelling and Simulation for Next Generation Ports at NUS, the Centre of Excellence in Maritime Safety at Singapore Polytechnic, and the Centre of Excellence for Autonomous and Remotely Operated Vessels work closely to address this problem statement. In this episode of SMI Research Spotlight Series, the project team will share each centre's contribution towards the project and how the research outcome can help to improve the navigational safety in our busy port waters. To find feasible solutions for a challenge at such a scale, we created a deep reinforcement learning model, the practical close encounter navigational engine, as the heart of the project. The model was trained with a variety of data studied by C4NGP, including variables and conditions surrounding near misses in Singapore waters, which was then classified into 26 distinct categories. To increase the validity and effectiveness of the DRL, C4NGP worked with CEMS and COPS to fully develop the model.
Drawing upon the expertise of ship captains and former seafarers within CEMS, we integrated the art of good seamanship with the collision regulations, including navigation guidance, to propose practical recommendations for ships to follow, especially when navigating in complex close-quarter situations. These validated recommendations will facilitate better decision-making for the bridge team to safely navigate through the busy traffic in Singapore Straits.
COPS contributed by introducing a comprehensive physics-based modeling of ship maneuvering that covered the different sizes and shapes of ships prevalent in Singapore waters. We modeled vessel motion behavior corresponding to the type and size of ships, including how a ship will behave and respond, covering how it turns, speeds up or slows down for different rudder angles and propeller speeds. This maneuvering model is an integral part of our deep reinforcement learning model to predict realistic vessel movements and interactions. Our model's capabilities extend beyond the application and generates data on ship behavior in near real-time tidal current conditions in Singapore's waters. This enhances vessel movement prediction accuracy.
The contributions and collective inputs from the project team enabled us to replicate the possibilities of one-to-many near misses and resulted in a state-of-the-art DRL model. We derived practical rules and communication protocols from the model's optimal policy, which is a unique and original contribution that complements COREX rules.
It complies with COREX and safety rules while giving us means to safely explore different categories of near misses and accurately run simulations in the digital space. The outcome of simulations enabled us to generate new rules to enhance the safety of navigation in Singapore port waters.
To ensure that our simulations and rules are practical in the real-world maritime operations, we reached out to our industry collaborator PSA Marine, who served as a crucial validation resource.
Singapore is one of the busiest ports in the world with high traffic within its port waters. We were eager to collaborate on the project to improve the navigation safety of our maritime stakeholders. The engines developed show us the possibility of AI assisting mariners to avoid close-quarter situations according to COREX rules and port regulations. As a harbour pilot at PSA Marine, we were able to share our professional knowledge and experience to help validate the simulations generated by the engine.
Our research work introduced a novel multi-agent soft actor critic algorithm with action masking, which can cope with the complexity of the environment and ensures safe multi-ship collision avoidance in compliance with COREX. The success of leveraging DRL models to solve complex problems, as demonstrated in the project, will result in more integration of that technology. From improved pilot advisory and autonomous navigation systems to enhancing existing simulators, the DRL model is an exciting new step towards improving safety and efficiency in the maritime industry.